Let's do another example. Okay, so determine whether the vector field is conservative. If it is, find the potential function. For the vector field. Okay, so this is a vector field in R2, therefore to see if this is conservative, we just want to know if ddy of the y component is equal to ddx of the x component. Okay, so they are the same. That tells us that yes, f is conservative. All right, so let f be a potential function. What does that mean? That means gradient f is equal to the vector field 1 over y negative x over y squared. Okay, so this tells you that you have two equations. One tells you df dy is equal to 1 over y. The other equation tells you df dx equals 1 over y, and df dy equals minus x over y squared. All right, so we have two equations, and we're gonna use both of them. So equation 1 tells you that if you integrate the function with respect to x, then you'll get an idea of what the function f should be. So that'll be x over y, because 1 over y, you are seeing this as a constant, right? So what you have is the constant times x, all right, plus constants in the eyes of x. So that's any function of y plus an actual number, right? Okay, so x over y equals plus g of y plus any constant is the general format of this potential function f. All right, so let's differentiate this function with respect to y and see what we get. We get minus x over y squared. Why? Because you are treating x as a constant, and 1 over y is nothing but y to the negative 1. So this gives you negative x times y to the power negative 2, and that is negative x over y squared. Okay, so this is a common trick that we can write a fraction in terms of power function, and we can apply power rule. So don't forget this. And then plus g prime of y, and the constant c goes away. All right, so now couple this with equation 2, you have negative x over y squared plus g prime of y equal to x minus x over y squared. Okay, so this right hand side is coming from here, and they're both df dy. They're both df dy. All right, so simplify this a little bit, you realize this and this, they're the same, you can cancel them out, and then g prime of y is equal to 0. So what does that tell you? That tells you that g is indeed nothing but a constant. Okay, all right, so now we put everything together. this is a constant, plug this back into the format, the general format we have from equation 1. The c here can be arbitrary constant, the c here can be an arbitrary constant, so we can just write them together, and therefore you do have just a very simple form, a function x over y plus a constant. Any constant is a potential.